Hey everyone, Nicholas JMV here. Welcome to how to find the length of a curve of parametric equations, parametric functions. So the definition, depending on what you're looking at, the length is the integral from a to b of the square root of dx dt squared plus dy dt squared, all taking the derivative or the integral with respect to dt. If you're using Barron's guide, they show you this little guy. So the length of a curve here is dy squared plus dx squared equals ds squared. So a couple ways to write that. The first example is going to just ask you to set up the integral. We have x equals tangent of t, y equals secant of t, and we're going from 0 to 4. We want that length, but they tell us, hey, just set this up, don't evaluate. So what we're looking at is x equals tangent of t, y equals secant of t. So let's go ahead and take those derivatives, dx dt. The derivative of tangent is secant squared. And the derivative, dy dt, of secant t is equal to secant t tangent t. Okay, there we go. So far, so good. Now, the length is equal to the lower and upper limits of integration. They said t equals 0 to 4, or pi over 4, excuse me, times the square root of our derivatives squared. So secant squared t squared plus secant t tangent t squared dt. Okay, so that just goes from 0 to pi over 4, okay, of the integral of the square root of secant to the 4th t plus secant squared t tan squared t dt. And there is the integral set up but not evaluated. That's one where you probably use Math 9 to help you out. All right, so our second example, the position x, y of a particle is given by, at time t is given by x equals t squared and y equals t cubed over 3 minus t. Find the distance the particle travels between 0 and 1. So x equals t squared, dx dt equals 2t, y equals t cubed over 3 minus t. And if I take that derivative, dy dt equals t squared minus 1. Okay, so now let's set up the formula. We're going from 0 to 1. So the length is given by the integral from 0 to 1, or I think it's 0 to 1. Let's see, 1 to 2. 1 to 2 of the square root of 2t squared plus t squared minus 1 squared, all that dt. Now, if you have Math 9, you can do that on your calculator, but we'll keep going. So we're going from 1 to 2 of the square root of 4t squared, right, plus t to the 4th minus 2t squared plus 1 dt. Okay, we can simplify that even more. So from 1 to 2, okay, you get t to the 4th. 4t squared minus 2t squared is plus 2t squared plus 1 dt. You get this beautiful perfect square underneath. So from 1 to 2 of the square root of t squared plus 1 squared. Okay, we're going to run out of room. We need some more paper here. Okay, so the integral from 1 to 2 of the square root of t squared plus 1 squared means from 1 to 2 of t squared plus 1 dt, right? The square root and the square cancel. So now we're just going from t cubed over 3 plus t, evaluating that from 1 to 2, and you end up with 10/3. So that is how you calculate the length of a curve of a parametric function. So if you guys have any questions or comments on how to do that, let me know below, and we'll see you next time.